Let's do some review problems over sections 5.1 through 5.3. So the first thing that I want us to practice is drawing an angle in standard position. So we are looking at the angle -7 pi over 4. Remember, when you are dealing with negative angles, we want to be thinking about going in a clockwise position. But to help us out with this, we are going to need to think about angles in terms of radians. And so remember, we're always going to start with 0 radians on that positive x-axis, but I need to be thinking about the full rotation, which is 2 pi. So I'm going to take the denominator of my problem, and I'm going to be converting 2 pi into that denominator. So I'm going to put 2 pi over 1. I want to turn it into a denominator of 4, which means I multiply both the top and the bottom by 4. And so hopefully we're all okay with the fact that 8 pi over 4 is really equivalent to that 2 pi, which is 1 full rotation. Now, because that angle is a negative angle, I want to think of my rotation as heading towards negative numbers, so I want that to be -8 pi over 4. Remember, we are going then in a clockwise position. The fastest way then is I'm going to go to the halfway mark, which was over here on the negative x-axis. Because my denominator is 4, but halfway we would be thinking about negative pi. I want this to be -4 pi over 4. So then now that we know the starting point at 0 and the halfway mark at -4 pi over 4, I can cut that in half, and that will get me what the bottom negative y-axis is. So half of -4 tells me that -2 pi over 4 is down here at the bottom. So then essentially, as I'm moving clockwise, every quadrant, or to get to each axis, I'm essentially then subtracting 2 from every numerator. So that's why then -2 pi over 4, when I subtracted 2 in the numerator, took me back to that -4 pi over 4. So now if I subtract 2 from -4, that tells me up here we're at -6 pi over 4. Subtract 2 again, and that takes me to the -8 pi over 4. So because we are dealing with my problem and we are dealing with a -7 pi over 4, I don't have to keep going around in my quadrants or in my axes and keep subtracting 2 to the numerators, because -7 is going to fall within that one rotation. So -7 is actually going to fall here in the first quadrant because it's in between -6 and -8. So now that I know where that terminal side is, so I guess I'll switch colors here for a second. So remember, here's my initial side. It's on the positive x-axis. I just drew my terminal side, okay, in the first quadrant. And so now I need to finish drawing the angle by creating my direction in which it is rotating. So remember, we want to go in a clockwise position, and I start at that initial side, and I am going until I hit that terminal side. And that is going to be then, if we call this angle theta, this is my theta. Okay, so once again, it's not one full rotation, because one full rotation was -8 pi over 4, and -7 pi over 4 is just a little bit smaller. All right, so that's my answer. In the second one, we're going to use reference angles to find the exact value of the sine of -7 pi over 4. Okay, so I used the same angle as the first example, so then we can see that, hey, if I know where my angle is going to be located, I can very quickly, because we have to do this without a calculator, I could very quickly then know that I need to draw a picture of a right triangle in the first quadrant, because that is where that -7 pi over 4, the terminal side, is always then the hypotenuse of this right triangle that we're drawing. So because we're dealing with a denominator of 4, remember, when we're thinking about our special right triangles, we have 30-degree angles, 45-degree angles, and 60-degree angles for our special right triangles. The 4 in the denominator indicate that we are dealing with a 45-degree reference angle. So this triangle is a 45, 45, 90 triangle. And so with it being in the first quadrant, that means that every single side is going to be a positive one. If we think about then the relationships of the sides, I need to have each of my legs be the same because the angles across from them are the same. I always make the smaller sides 1. So if I make my legs 1, remember, you can do Pythagorean theorem to find your hypotenuse, or you can just know from your properties of a special right triangle that the square root of 2 is the hypotenuse. And now that I have that picture, I can find the sine of that angle. It's a 45-degree reference angle, but that sine, we're thinking about opposite over hypotenuse. So from this angle down here, opposite is 1, hypotenuse is the square root of 2. Last thing I have to do is rationalize. I'm going to multiply the top and the bottom by the square root of 2 to get rid of that radical in the denominator. That gives me a square root of 2 on the top. The whole point is that with this pair, it becomes a perfect square. It's really the square root of 4, which then is 2. So the sine of negative 7 pi over 4 is really the square root of 2 over 2. All right, in the next problem here, I'm giving you a picture of triangle ABC. B is the angle where theta is. I'm giving you one side is 3 and one side is 11. It's asking for us to evaluate the 6 trig functions. So that means we want to find the sine of theta, the cosine of theta, the tangent of theta, and then its reciprocals. So the cosecant of theta, the secant of theta, and the cotangent of theta. Be very careful. 11 is the side that's across from the right angle. That's your hypotenuse. So when you're thinking about your Pythagorean theorem, you need to understand that 11 is the biggest side. So to figure out this side, I'll call it x. I'm going to do x squared plus 3 squared, and that has to equal 11 squared. So 3 squared is 9, 11 squared is 121. We have to subtract the 9 from the 121 to get the x squared by itself. That's 112. Then I'm going to take the square root of both sides. And now we want to start trying to see if we can break up that 112. So notice that you're trying to look for some perfect squares. Two numbers that multiply to 112, 16 and 7. Notice that 16 is a nice perfect square. The square root of 16 is 4. So that means that 7 being a prime number, it doesn't break up any further. So 4 root 7 is going to be that side. Okay, so from the theta, that means that 4 root 7 is the opposite side and 3 is the adjacent side. So now that I have all that information, we can find our trig functions. Remember, thinking about SOHCAHTOA, sine is opposite, which is that 4 root 7, over the hypotenuse, which is 11. Cosine is adjacent over hypotenuse. Adjacent is 3, the hypotenuse is 11. Tangent is opposite over adjacent. So 4 root 7 is the opposite side from theta. 3 is adjacent. All right, now that I have that, I need to reverse them, and their reciprocals are these 3. So when I reverse and take the reciprocal, I notice that now I have a square root in my denominator, so we're going to rationalize. It's okay that there's a 4 down there. I'm going to multiply the top and the bottom by the square root of 7. That'll give us 11 root 7 on the top. Once again, the whole point is that this turns into a perfect square of 7. So really my denominator is 4 times 7, which is 28. The numbers that are outside of the radical, the 11 and the 28, don't simplify any further, so that's my final answer. But if that was like a 10 on the top, we would have to simplify and reduce down the fraction. Secant is just the reciprocal of cosine, so that would be 11 over 3. And then cotangent is the reciprocal of tangent, so that becomes 3 over 4 root 7, which once again, I don't want that radical in the denominator, so I'm going to multiply both the top and the bottom by the square root of 7. That gives me 3 root 7 on the top. And once again, the whole point is that 7 is underneath that square root twice, which means that it becomes 7. 7 times 4 is 28. Same idea as the cosecant. If the 3 and the 28 could simplify down, we would want that to happen. However, it doesn't, and so that would be my final answer. In this last example here, it says a diver is at the top of a diving platform, which is 20 feet high above the pool. The diver is looking down at his coach on the side of the pool. The angle of depression is 26 degrees. What is the distance from the coach to the base of the platform? And they're asking for us to round to the nearest foot. When we are asked to do these types of problems, we're thinking about right triangles because we are doing right triangle trig. Okay, think about the vertical side. Well, that's going to be where the guy is diving. The guy is up here on the platform. Okay, so up here, this is the distance. It says it's 20 feet high. So that is the height of the platform. Then it's saying the diver's looking down at his coach, which is on the other side of the pool. Well, this is where the pool is. This is the pool. The coach is down here. So notice that angle of depression, remember, means that you're thinking about looking straight ahead, and then your eyes are depressing. They're looking downward. So from your line of sight straight ahead, looking down, it's this angle out here, which is 26 degrees. So then there's a couple different things that we need to do with that angle. We could find what I just labeled as x, which would be its complementary angle. So remember, we can find the value of x by taking 90 minus 26 and getting that angle. Or the other way to think of it, if I delete the pool here, is that that angle of depression is actually congruent to this angle inside at the bottom. Those are what we call alternate interior angles if you're thinking about geometry. So either way, you can use the angle that you can find for the measure of x, or you can just stick with 26 and know that it's down here at the bottom. The question says, what is the distance from the coach to the base of the platform? Anytime they talk about a base, they're talking about the bottom. So we're not talking about the hypotenuse in this problem. We're really talking about this bottom piece. So I guess I'm going to call that A. Okay, so now that I have this picture, I think I'm going to stick with the 26 degrees. So notice how 26 and the 20 is the side that is opposite it, and the side that I want is the adjacent side. So that means opposite and adjacent, I'm using tangent. Now make sure in your calculator you are in degree mode because we're talking degrees. So the tangent of 26 degrees is going to equal 20, which is opposite, over A, which is adjacent. So to start solving for A, I got to get rid of that denominator. So I'm going to multiply both sides by A. Now A is being multiplied by the tangent of 26 degrees, which means to undo multiplication, I'm going to divide both sides by the tangent of 26 degrees. So in my calculator, I'm going to be very carefully typing 20 divided by the tangent of 26 degrees. I know I'm in degree mode. It's telling me to round to the nearest foot. Well, I'm getting 41.00607, so on and so forth. So that means that 41 feet is going to be that distance. Okay, so that's just a quick little recap of some of the problems from sections 5.1 through 5.3. If you have any questions, please reach out to me and we can do some more practice together.